So good afternoon, everyone. Welcome to the webinar of Gen AI. Today we'll be discussing about what is prompt engineering, how do we give inputs, how do we give inputs to each and every model that we're going to build, right? So I'll be discussing what is RAG versus fine tuning, what is the role of prompt engineering in both the approach, some key prompting techniques like zero shot, few shot, chain of thought, zero thought. Apart from that, self-consistency, tree of thought, etc., these kind of fine-tuning prompt engineering techniques. These concepts are central to know how the modern LLMs will adapt to different tasks efficiently without massive retraining. So what exactly is prompt engineering in the first place? Prompt engineering is the practice of designing effective inputs called prompts to guide large language models like GPT or Claude or DeepSeek towards any desired output. It's like asking a smart assistant the right question in the right way. The better the prompt, the better the result without changing the model itself. Prompt engineering can include a lot of things like formatting the inputs, giving examples, asking intermediate questions, okay, or setting roles or instructions. It's a lightweight and cost-effective alternative in order to retraining or fine-tuning. So first, let's understand what is RAG and what is fine-tuning and what is the difference between the two. Fine-tuning will update the model's internal weights using new data. What are the advantages of fine-tuning? Deep knowledge and tailored response, right? To whatever data that you are looking for, you get a tailored response. Again, fine-tuning also has its own cons and disadvantages. One would be that it's quite expensive, okay, going to cost you more. It's kind of time-consuming, takes a lot more time, and it is static in nature. Rather, RAG is another technique, which is RAG stands for basically retrieval augmented generation. Retrieval augmented generation will combine a pre-trained LLM, okay, a pre-trained LLM with a retriever. Instead of remembering everything, the model will look up relevant documents at the inference time. So the advantages of using RAG is it will have up-to-date information. It is flexible, no retraining required. But certain disadvantages include it will depend on retrieval quality, how fast and how smartly you can retrieve the data from the reference document. So we can take an example. Fine-tuning is like updating a textbook, and RAG is like using a search engine while writing an answer. So what exactly is the role of prompt engineering in both, in fine-tuning and RAG? Prompt engineering will help the training format, okay, in case of fine-tuning. What do we mean by training format? Basically, how the questions and answers will be structured, right? This is what prompt engineering will control in the fine-tuning approach. It can improve data quality before the training. Whereas RAG, in retrieval augmented generation, prompting becomes even more crucial. It will define how retrieved documents are injected. It helps you balance between retrieval and generation. It can format prompts to guide how the model interprets the external data. So prompt engineering often complements both the methods. It helps fine-tuning and RAG both. It helps RAG without retraining, and it makes fine-tuning more sample efficient. So it is used in both of the techniques and both of the approaches. Okay, now we'll go to the coding part and maybe understand a little bit about the different type of prompting techniques. So the first thing that we've done here is install the required libraries. So we have our transformers library from Hugging Face and Accelerate also. And the fact that I am putting an -q here, make sure that everything is installed very efficiently and suppresses all the internal warnings. Then we import certain required libraries and initialize the model itself. So we're from the Transformers library of Hugging Face, we're importing the pipeline module. And using this pipeline module, we will install our language model basically, right? So we're loading a small instruction tuned model for the task, text to text generation task. We're installing the model Google Flan T5. It's a small model. It's basically a lightweight model for free inferencing by Google. And we're limiting our response, maximum response length to 100. So we don't want huge tokens. Again, we have kept on repeating repeatedly what tokens are. Tokens are nothing but words, or I can say small meaningful units, right? Can be called as tokens. And then we're setting the model with the processor. So if CPU is available, it's going to take CPU model. If it is a processor, or if GPU is available, CUDA GPU, then it will connect to CUDA GPU. Here it's saying that device is set up to use CPU and model has been loaded successfully. Okay. Then we're creating a universal function in order to generate the following responses. So I'm defining a custom function here. The name of the custom function is generate underscore response. It is going to take the argument input prompt is going, the prompt that we're going to use will be the input argument here. Okay. This function says this function will send a prompt to the model and return the generated text. So response is equal to generator of prompt. So what exactly is this generator? The model basically, right? This model pipeline, whatever we have loaded. It will take the input as the prompt argument, and then it will generate the responses. It will extract the generated text part. Let's see. We'll define a lot of different prompt techniques here. So coming forward in the series, we started with prompt engineering today. So today I'm just going to give you a brief introduction about a few prompting techniques. Going forward, next week and further weeks, right, we'll explore each and every prompting technique in detail. So first, let's talk about zero-shot prompting. Zero-shot prompting is a method in which no examples are given. The prompt is used when task is very simple or the model is very well trained, right? We can see an example here. We're giving a prompt with the variable name paragraph. We're saying we have a text here which says natural language processing NLP is a field of AI which focuses on the interaction between humans and computers using natural language. And I'm giving a zero-shot prompt, which is a direct question or a direct task without any examples. The zero-shot prompt says extract the top 3 keywords from this following paragraph. So from this text or from this paragraph, you need to extract the top 3 keywords. And I'm going to call this function using this zero-shot prompt argument. And once I say generate the response, it will display the response. The top 3 keywords within the paragraph are computer, language, and processing. Okay. Another example of zero shot I could say would be just a prompt, very simple prompt saying that translate the following sentence to French. So straight away I'm giving the task, no examples. This is used when the model is well trained or when your task itself is a very simple task to perform. Okay. Then we also have few shot prompting technique. Then what is a few shot prompting technique? Few shot prompting technique is when we provide 1 or 3 examples, 1 to 2 or 1 to 3 examples are given in this prompt. This will help guide the model to get the desired output. For example, when you say translate these, for example, hello is being translated to bonjour, goodbye is translated to au revoir, and then now we are saying translate thank you. So I've given a few examples of translations and then I'm asking, go ahead and translate the further ones. So you can see here, they're giving some prompt here. They're saying extract keywords from the given text. Here also we're trying to extract the keywords, but now we are giving some sort of example. First example says that the text is artificial intelligence is transforming healthcare. Keywords in this above text are artificial intelligence and healthcare. Another example too we provided which says cloud computing enables scalable applications. Keywords out of this second example are cloud computing and scalable applications. Now I'm saying it's your turn, the model's turn. The text that we're giving here is deep learning is a subset of machine learning that uses neural networks. What are the main keywords in this particular text? And we are asking it to generate the response by calling the custom function. It is generating the response saying deep learning and neural network are the keywords in this above text. Right? This is few short prompting where we give a few examples and then we tune the model to sort of give us a desired output. Then we also have chain of thought prompting. What is exactly the chain of thought prompting? Right? Chain of thought prompting is where you are encouraging a step-by-step reasoning. What does that even mean? The prompt will guide the model to explain its reasoning in a step-by-step manner. It is especially helpful when we are using it for any sort of complex tasks like mathematics or any kind of logical tasks. For example, I can say a prompt saying, let's think step by step. You see the example here. In the example here, we have step one says, so we're saying extract the keywords from the paragraph. Step one says identify the important nouns and noun phrases. And then after identifying important nouns and noun phrases, then you choose the top 5 relevant ones. And what is the text we are giving? NLP enables computers to understand human language such as English, French, Mandarin, enabling applications like chatbots and translation services. So chain of thought response is giving that human languages such as English, French, and Mandarin, enabling applications like chatbots and translation services. It is picked out. It is first identifying important noun and noun phrases. Then it is coming down to top 5 relevant ones. Right? That's how chain of thought works. Then we also have something called as self-consistency prompting. What is this technique? A technique which is used in chain of thought where the model is run multiple times and then different reasoning paths are compared. The final answer is chosen based on the consensus. This will improve the reliability by averaging over multiple thoughts. So it will start multiple reasonings, multiple paths of thinking. And whichever path of thinking, it will take the answers or outputs of all the paths of thinking, and whichever is most commonly generated output, it will choose that as the final output of the model. For example, you can see here, identify keywords from the following paragraph. Think carefully, reason out the possible options, and then double check before finalizing. The paragraph is quantum computing is poised to revolutionize fields such as cryptography, material science, and complex system simulations. So from here, we need to generate the keywords. So it is generating the keywords quantum computing, technology, and revolutions. Then we have the finally another last prompting technique that we'll discuss, which is tree of thought prompting. Now, what exactly is this tree of thought prompting, right? TOT. It further expands on the chain of thought, but instead of generating one linear reasoning path, it will branch out in like a decision tree. So in ensemble methods, we have seen decision trees. It's something similar to that. At each step, the model will consider multiple possible thoughts or multiple next actions that it's supposed to take. These branches from a tree of potential solutions. There is a search algorithm like the BFS or DFS is then used, which is to evaluate and choose the most promising path. It is useful in solving, complex problems with multiple reasoning paths. It will work when you're doing planning or, you're solving puzzles or you're actually using decision-making tasks. It will allow for error correction and better exploration. Let's see an example. So we're saying let's extract keywords by exploring multiple paths. One way to identify keywords, path one would be you focus on the technical terms. Another logic would be focus on industry or applications. Another logic would be focus on the benefits and future possibilities. So either of these three logics you can take, whichever gives you the most common answer, get into that. That will be the keyword. So you can see the paragraph here. The paragraph here says generative AI can create new images, text, and videos, driving innovation in entertainment, marketing, and design industries. Let's begin by branching our thoughts. So once we call this generate response function, custom function, along with the input argument tree of thought prompt, we get the output that the keyword coming from multiple paths, common keyword from multiple path 1, path 2, path 3 is actually AI industry. So this is just a gist on how we can use different types of prompting techniques to get the correct answer. To conclude, I would say that, RAG and fine tuning, both are two powerful methods to specialize your LLMs for your desired application. Prompt engineering will boost both RAG as well as fine tuning approach by guiding model behavior without any internal changes. So these kind of techniques like zero shot, few shot, chain of thought, tree of thought, self-consistency prompting. A lot of plethora of promptings that we'll also deep dive into in coming few sessions. All these prompting techniques will help us unlock more reliable and intelligent outputs. So instead of heavily focusing on the LLM and tuning the LLM or doing RAG of the LLM and basically changing the structure of the pre-trained model, instead I can incorporate different prompting techniques in order to get the best desired output out of our model. That's where prompting techniques will come into picture. Next sessions, we'll go down, probably next week, we'll deep dive into one of those prompting techniques. Over the next few weeks coming up, we'll deep dive into each and every prompting technique. So that's it for today, guys. Thank you so much for joining in. Thank you for joining in with the Generative AI series, learning series with 360DigiTMG. If you like and find this video to be informative, the coding part to be informative, do let us know in the comments. Thank you so much.